We've got another system of inequalities, and we need to graph the feasible region and find the corner points. All right, so let's start by drawing our xy plane. All right, and the first inequality that we have is x plus y is less than or equal to 7. So remember, the first thing we need to do is graph the line x plus y equals 7. And if we know that x plus y equals 7, then if y is 0, the biggest x can be is 7. And if x is 0, the biggest y can be is 7. Great, and we know we have to be below that line. So we can connect these up. And this is our first line, and we have to be below it. So this inequality is satisfied anywhere on or below that line. All right, for the next one, we can do the same thing. If x is 0, and we're looking at the line negative x plus y equals negative 3, if x is 0, then y is going to be negative 3. So that's 1 point on it. If y is 0, in the line negative x plus y equals negative 3, then x can be 3. And so we connect those 2 points. And then we have to think, are we above or below this thing? Well, we're greater than or equal to negative 3, so we have to be above. And then finally, we have this third one. So again, we're going to consider the line 3x plus y equals 13. If x is 0, then y is 13. And if y is 0, then we can divide both sides by 3, so x is 13 over 3, which is just bigger than 4. So 4 is right there, and we're just past it. And so this is the third one, and we have to figure out if we're above it or below it, but remember, we're greater than, so we're above. So we're above this one, we're above that one, and we're below that one, so our feasible region is that little triangle in there. And this one you can see is much harder than the past one, because now I can't just look at this and say, oh, I know exactly what the corner points are. We're actually going to have to do some algebra here. So these are our 3 corner points. And let's start by looking at that one up here. So what are the 2 lines that intersect at that point? It looks like line 3 and line 1. So 1 is x plus y equals 7. 3 is 3x plus y equals 13. And so if we're going to figure out what x and y are at that point, we can subtract. We can do this line minus that line. So we'll get negative 2x, y minus y is 0, and then 7 minus 13 is negative 6. Divide both sides by negative 2, so x is equal to 3. And then we can take that 3 and plug it back into the first one. So 3 plus y is equal to 7. That tells me y is equal to 4. And that tells me that that point is the point 3, 4. So we found the first of our corner points. All right, now let's try another one. So the 2 lines that intersect here are lines 2 and line 1. So 1 and 2, that's x plus y equals 7. And negative x plus y equals negative 3. All right, well, it looks to me like we can just add these together, because then the x's go away. We get 2y is equal to 4, so that means y is equal to 2. And if y is equal to 2, we can plug that 2 back into the first one, so x plus 2 is 7, so x is equal to 5. And that means that that corner point is 5, 2. And now we have one more left to do. We have this bottom one right here, so let's go and do this work up there. So on this bottom point, it's lines 2 and line 3, so negative x plus y equals negative 3. And 3x plus y equals 13. And again, what we can do is the same thing that we did for this one. We'll subtract. So negative x minus 3x is negative 4x. y minus y is 0, and negative 3 minus 13 is negative 16. Divide both sides by negative 4, so x is equal to 4. And if x is equal to 4, we can plug that into either one of these that we want. If we plug it into the second one, we get that 12 plus y is equal to 13, so y is equal to 1. And so that corner point is the point 4, 1. So we found our 3 corner points after we found our feasible region by looking at which 2 lines intersected and doing a little bit of algebra to figure out the point at where they met.